Hey, welcome back. I hope you got coffees and visited some of our exhibition booths. But I am about to announce our next headliner, who is Philippe Rambach, who is Senior Vice President and Chief Artificial Intelligence Officer at Schneider Electric. You may have caught him on a panel yesterday, and he's going to be talking on the subject of AI for smarter energy decisions and efficiency. And he's going to share how AI can help optimize energy consumption and enable sustainable decision-making by predicting optimal energy usage based on energy prices, balancing consumption spikes, and reducing emissions. So, without further ado, over to you, Philippe. Please give him a big hand.
Good morning, everyone. Bonjour à tous. And thank you to take the time to listen to what we want to share with you today. If you listen to the news, if you watch TV, if you read social medias, you may read often that AI may bring humanity to its final day through large language models, general AI, all of that. What I want to share with you today is something probably much more positive, is that, as you, I guess, all know, humanity is facing an actual risk, a true danger, which is about climate change, global warming, and the impact of human activity on our planet, on our global warming. And the good news is that we believe that AI, artificial intelligence, digitization, electrification, can really contribute massively to reduce the carbon footprint and reduce the global warming effect. So AI can also be used for things which are extremely important for humankind as a global, in its globality, and for the good. So why am I speaking about that? Maybe a few words about Schneider Electric. So Schneider Electric is a Fortune 500 company, 30 billion euro revenue, and around 140,000 employees all over the world. And what we do is we provide a solution to optimize and manage energy, optimize industrial automation, optimize industrial operations. I'll let you read what we write here, but fundamentally, what we want to do as Schneider is to help our customers, help the world be more sustainable. And to be more sustainable, to really fight against carbon footprint, against carbon emission, I would say there are fundamentally two different approaches, two different ways to do it. One way is to drastically change our way of life, to totally change our living condition and reduce our carbon footprint, carbon emission. The other one is to find ways to continue to produce same amount of things, to live in the same kind of condition, but using much less of the resources of the planet, using less energy, and most important, using energy in a way that emits much less carbon. So that's what I want to speak about today, which is really how you can use AI to reduce the carbon impact of our needs for energy. And energy is, of course, one of the massive contributors to the carbon footprint and the carbon emission. So let's start by good and bad news. Let's start by the bad. Although we all know that it is really now time to act, to reduce carbon, and to fight against global change, we continue to waste around 60% of the energy that we produce. And not only we waste 60% of the energy that we produce, but most of this energy, the one wasted and the one not wasted, still come massively from coal-based energy. I name it oil, gas, coal, etc. So that's for the bad news. On the good news, there are technologies today, and I will share some of them, where we really believe that 70% of the carbon emission that are linked with using energy can be actually removed with what exists today. So let's start a bit by what would a more electrical world look tomorrow. You would have generation done by renewable, like solar panels. You would have generation done by wind. You will have microgrids, which would be local autonomous energy production and energy usage at the same time. You will have some energy storage. You will also have buildings which are much smarter than the building we have today and therefore much more energy efficient. You will have homes that will be smarter and more efficient. And of course, you will have the gigantic impact of the electrical vehicles, both on impacting both the carbon emission, but also impacting, of course, the amount of electricity needed to fuel the world. I will focus on how AI can help us reduce our carbon emission, carbon footprint, and energy, and I will start by taking the example of buildings. I don't know how many of you know, but the building experts would say fundamentally that buildings represent 40% of the carbon emission, and a lot of that comes simply from heating and cooling buildings. And today, there are solutions to drastically reduce the carbon emission, the need for energy in buildings. We say that using the right technology, you can reduce by 30% the energy usage needed to cool, heat buildings. It starts by basic automation. It starts by sensors. Something as simple as you are in a room, somebody open the window, do we have an automation to stop the heating of that room? But then the next level will come from sensors in the building that will monitor how the building is used. When do people arrive in the morning? When do people leave in the afternoon? What do they do at lunch break? What rooms are used? What rooms are not used? It will also take sensors that measure things like humidity, temperature. And coming from all this data, which can be easily gathered with technology, we can develop, and we actually develop, AI-based algorithms, machine learning. We will be able to learn how the building behaves. We will be able to predict how the building behaves. And by doing that, you are able to drastically reduce the amount of energy needed in your building. I take a couple of examples. If you are able to learn what is the global behavior of people, depending on the days of the week, depending on the weather outside, depending on whatever input parameters you have entered, you will be able to decide someday to open only half of your building, or to totally close one room, or to not use that room this day because this is the one which is consuming the most energy, etc., etc. So you will be able to really optimize the way you run your building. You will be also able to learn by machine learning how your building physically behaves, which means how does it react when you start to heat it and cool it, how long does it take, depending on all the conditions, to bring it to the right temperature. And therefore, you will be able to decide some days to start your heating system or your cooling system 1 hour before people arrive, or 5 minutes, because that will be enough. And all of that, without impacting in any way the comfort of the users of the building, will give you close to 30% of energy saving. So that was one example out of this complex electrical world where we have already, the world has already technologies with data, sensors, machine learning, AI, to be able to learn how buildings behave, forecast what's going to happen, and from that, really optimize the way we use energy in buildings. Now, if I take a step back and look at really what we can and should do collectively to really address, or at least try to contribute to reduce carbon footprint and climate change. The first pattern is really about efficiency and digital. If I come back to this building example, but you can have the same for data centers, for factories, for your own individual homes, you are able to reduce the amount of energy that you need by collecting data, automating, and using AI to define the best strategy of usage. So the first point is really, we will need to achieve the world transition to a new energy world. We will need more digital to be able to be more efficient and basically need less energy. The second thing is, of course, it's great. Let's say you have done all of that. You have reduced by 20 or 30% your amount of energy needed. If you still power your process, your data center, your buildings by burning oil, gas, or coal, you are still, of course, contributing to the carbon footprint. So the next step is to electrify the processes as much as we can. Electricity today is the only energy that can be fully decarbonized. It is not always fully decarbonized, of course, but that's the only one that can be fully decarbonized. So first, digital efficiency, digital to understand the process, AI to optimize the process, then electricity to make sure that we use a source of energy that can be decarbonated. And by the two together, we believe that it can really strongly contribute, double-digit %, to a more sustainable world. But of course, let's say again, you have digitized your building, your factory, your home. You have used AI to optimize, to reduce your energy need. Then you are still an excellent citizen. You have also electrified everything. If your electricity coming to your home is still produced by burning oil or burning gas or burning coal, you are kind of back to square one. So the next challenge will be the new energy landscape, which means that we will have, and we need to have, in the production of electricity, more and more renewables. And that has a lot of consequences. And I will start with the first one. Yes, you will have big solar panel, big solar farms with gigantic installations, but you will also have a lot of decentralized electricity production. Let's take, for example, a large airport, a large shopping mall, a large university. You will be able to find in such a place production of electricity because you will install solar panels, wind generation, maybe sometime even diesel generation. You will have some batteries to store what you produce when you need to reuse it later. And that's what we call prosumers, so people who, at the same time, are producing electricity and consuming electricity. But that brings another challenge. Let's imagine that you are running an airport with a nice installation with solar panels, some batteries, and you are connected to the electrical grid. Every minute, every 15 minutes, every 30 minutes, you have to make a choice. Let's say the weather is sunny as of today, so your solar panels produce electricity. What do you do with that? Do you decide to use it immediately? Do you decide to use it to store in your battery for future usage? Do you decide to sell it to the grid? Do you decide to buy from the grid? So all that complex decision will require two things: an ability to forecast what is your need for the coming hours and coming days. And that's one, again, when machine learning can help a lot to build this ability to forecast your need. And then you will need to optimize and make the decision based on your needs, again, on what source of energy you use. And what I love in that microgrid example, or this prosumer example, is that we are not in a situation where you have to make a choice between cost and carbon footprint. Because by doing that, you will usually improve your cost by making sure that you buy from the electrical grid the electricity when it is cheap, and that you rely on your own production when electricity is expensive. And the good news is that usually cheap electricity comes from renewable. When expensive electricity is created at peak time, when the electricity producers need to run gas-powered station, fuel-powered station, to make sure to close the gap between the demand and the production. So usually, expensive electricity is also heavily carbonated. So a very positive thing where we can, at the same time, optimize revenue, optimize cost, and reduce carbon footprint. An example of something we did for the logistics centers of Lidl in Finland, where we combined those two approaches. We have combined the optimization of the building consumption to reduce as much as possible the core needs for energy, and at the same time implemented renewable controlled by a microgrid optimization system using AI. And by doing that, we have been able to reduce by 40% the carbon emission of this logistics center. And on that, nothing is not available today. That's why I come back on my first point. We do have the technologies today, using data, using AI, to drastically reduce our impact on the planet and our carbon footprint. So, if I come here to this last slide, what I really believe is that without AI, the energy transition will be actually almost impossible to happen for a couple of reasons. First, if we don't use AI and data and optimization to globally reduce our needs for energy, we will not be able to install enough renewable, to install enough green electricity to provide everything we need. The second thing is the complexity of the electrical installation, what I explained to you with the decentralization of electricity production, the fact that we are coming from a centralized production to solar panels everywhere, wind everywhere, where consumer and producer are in the same place. This is not anymore manageable with a single rule-based model. We're going to need AI to forecast and optimize that. So really, AI, from my point of view, is really the unlocker for energy management and industrial automation, efficiency. And efficiency itself is the unlocker for sustainability. And when I look at the critical applications for AI in the coming years, once again, renewable management will need AI to be able to forecast the load, to be able to optimize, because by nature, renewable are an intermittent source of power. They are not constant, so you need to be able to forecast your future needs and to optimize their usage. Demand management, reducing the demand, making sure also that we try to avoid the peak of production. As you know, in electricity and energy, you need at the same time to balance the power that you produce and the power that you consume. So you can also use AI to optimize the way you use your energy, make simple decisions, like at your home, we provide solutions where you can decide to postpone by an hour the start of your water boiler. You won't see the difference, but if by doing that you can avoid the peak of demand on the electrical grid, then you will avoid the local producers to start gas-powered station, and you will avoid, again, carbon footprint. So managing the demand, having in mind that we want to shave this famous peak of demand to avoid to use this highly contributing to carbon source of energy, of electricity, is another key point for AI. And of course, more classical infrastructure management, asset, process optimization, all of that, AI will help us in the coming years. So fundamentally, if I summarize what I wanted to share with you today, AI can be an incredible contributor with data and digitization to reduce our carbon footprint when we speak about energy management. It can help us to be more efficient, more green, more electrical, and therefore more sustainable, and it can help us today. So really encourage you to not only look at the potential bad usage and bad things with AI, but really on the positive, on something which is real, which is coming on us, which is climate change and global warming, and AI can truly help us. Thank you very much for your time and listening.
Thank you, Philippe, for a talk on a very critical subject. I can see hands in the air already. Oh, lots of hands in the air. Okay, well, I saw a lady in the kind of third, fourth row back here first. Just the luck of the draw. There we go. Thank you very much.
Hi. Can you hear me? Oh. Hey, thank you so much for the incredible talk. My name is Ashley Bach. I'm a student at McGill University. And I think you're completely right about the potential of AI being used to decrease our energy emissions. Well, sorry, our energy and our carbon emissions. And I was wondering what you thought about the actual energy required for AI. So in terms of this big increase we're going to see in all the computational power it's going to need and the related energy, how is that going to affect it maybe in a more negative way, and how can we deal with that?
Thank you, and that's a question we should never forget. If on one side we save energy, but we use so much energy to save energy, it's a kind of catch-21 game. So the question is good. I would say at this stage we are fairly lucky, because when I look at the kind of AI we need to optimize buildings, to optimize renewable, it is relatively small data AI. We're not talking of billions of parameters and gigantic need for computation. So at least as of today, the balance is super clear. These algorithms consume a very small percentage, less than 1% of the savings they can bring. But your question is good, and we always ask ourselves, okay, we have done an algorithm, it brings X% savings. Do we really want to refine to bring X plus 1% and then add complexity and add a lot of needed for more computation? So the first thing I would say, when you look in itself at AI for energy saving, the balance is clear and very positive. Now we can also help on things like large language models or other heavy demanding applications for AI. These things are powered in data centers. And the way you will power your data center, are you using green electricity? Are you using not green electricity? How do you optimize your cooling? We also work on that to try to reduce the impact on the environment of heavy computation like large language models and so on.
Yeah, that's great, like a process of evaluation, I guess, constantly. More hands. Can we see those hands that didn't get chosen the last time? Oh, sorry. Yeah, there we go. Perfect.
Thanks very much. Just on the compute and storage that's required, are you running this, or what do you recommend in terms of on-prem versus cloud? What do you see as more advantageous?
I would say that's also a very good question, which comes very often when we speak with our customers. And my answer would be, it depends. Obviously, running it in the cloud make it more easy, more efficient, more easy to maintain, more easy to update, more easy also to make sure that you use green electricity, because data centers now are very well powered with green electricity. At the same time, you may have some industries who really can't afford to have these models running in the cloud for security, safety reason, and we can definitively make those models also work on premises. It's more complicated, the maintenance is more heavy, but it is feasible. So for me, this question of premise or cloud, on-premise or cloud, should not be the blocking point to go for energy savings. Both can be addressed with, of course, an easier implementation when it is on the cloud.
Thank you very much. A very practical question. Oh, there we go. Perfect. Yeah, microphone there.
Thank you. Thank you for the presentation, Philippe Baguette from Fujitsu. I was wondering if in your models you also take into account the environment of the building, like trees or not, planting trees, planting shrubs, because indeed it has a great impact, or it can have a very positive impact on the consumption.
Absolutely. You need to take a lot of parameters to make this model making sense, and we definitively take this kind of environment into it. That is absolutely critical. Definitely, yes. The answer is yes, absolutely. And the more we'll understand, and maybe just to add on that, I love your question because that also touched something that I hadn't enough time to share here, but I also believe that the future of AI will need a combination of domain knowledge and AI knowledge. A core data scientist cannot by itself know that trees should be a parameter he should take into account in his model. If you combine the domain knowledge of people who work since ages in buildings, HVAC cooling, and knowledge of AI people, then you will put the right parameters in the model to get the right model.
Thank you very much. And we're going to go lastly to this gentleman in the front row.
Merci Philippe. Juste un mot en français, merci. Super claire présentation. Schneider Electric était mon premier employeur, donc encore plus heureux de vous voir sur la scène. I'll ask my question in English. The more you add sensors, the more you add technology, the more you add AI, the more you add cyber security risks, buildings, airports, etc. So what's your perspective on that, and what is Schneider Electric doing in this manner?
So that's, again, a real question. We work on it. We have worked a lot, and I see some people of Schneider in the room who work on that. We worked a lot on what we call OT cybersecurity, because as you know, a lot of cybersecurity was more designed for the IT world. So we have worked a lot on the OT world to see how we can really improve cybersecurity. We, by the way, use also AI techniques here to classify and identify wrong behaviors, weird behaviors. So no magic answer to that, definitively. One of the answers could be the on-premise story. If you are in a very, very, very risky industry, you can also decide to keep everything locally and not exit anything. Makes things more complicated, but technically feasible. And then we work to try to cybersecure that. That's one of our big activities, because the cybersecurity of OT is an enabler not only for AI, but for all automation and a lot of future progress. And we need to have the right level of cybersecurity so that it doesn't become a blocker, definitively.
Thank you for those questions. We are out of time now, but Philippe, I believe you might be hanging around. If anyone wants to grab you and ask a question, I know there were lots of hands there. Everybody, please give a big hand to Philippe Rambach.
Thank you.
Thank you. So, moving on.